So in the previous 3 videos, we proved the sine, cosine, and tangent angle addition formulas. In this video, the goal is to use that knowledge to come up with the sine, cosine, and tangent angle subtraction formulas. And it turns out we won't need that much more information. All we're going to end up needing to prove these 3 angle subtraction formulas in red are our 3 angle addition formulas in green, as well as the fact that the cosine function is an even function and the sine function is an odd function. If you remember what those terms mean, great. If you don't, here's the quick definition. All I'm saying is that if you look at the cosine of the negative of some angle, that's the exact same as the cosine of that angle. So the cosine of, I don't know, negative pi over 6 is the exact same as the cosine of pi over 6, for example. You could probably convince yourself of that fact pretty easily, maybe the unit circle or something. Another way you can do it is just by taking a look at the graph of cosine. If I consider the height of this graph when I go to the right and to the left, so for any arbitrary angle, if I look at the height at that angle and the height at the negative of that angle, these 2 dots right here, the heights are going to be the exact same, right? It doesn't matter which angle I choose, the heights are always the exact same. The height at the negative of an angle is the exact same as the height at an angle. What I'm saying is that the cosine of negative t is equal to the cosine of t. For sine, however, that's not quite true. The sine of a negative angle is not the same as the sine of the positive of that angle. The sine of negative pi over 6, for example, is not the same as the sine of pi over 6. But they're close. They're only off by a negative sign. And again, you could probably convince yourself of that just by looking at the unit circle, or you could use a program like Desmos, like I'm going to do here, and just consider the graph of sine. If you take any arbitrary angle, so I don't know, whatever this is right here, the height of this purple dot is almost the same as the height of this red dot. It's just one is positive and one is negative. And there's nothing special about this arbitrary angle that I chose. We can do that for any angle. The heights of these 2 points are always almost the same, just one is positive and one is negative. That's the defining characteristic of what's called an odd function, and it just means this fact right here. If you'll grant me all of that, I can pretty easily come up with these sine, cosine, and tangent angle subtraction formulas, because all we have to do to think about the sine of a minus b is use the angle addition formula. And you're like, how are you going to use the angle addition formula? It clearly says subtraction here. True, but a minus b is the exact same as a plus negative b. And for the sine of a plus negative b, I can just plug into this sine angle addition formula, except change all of the b's into negative b's. And that won't quite give me the angle subtraction formula that I want in red up here, but I can simplify this because I know what the cosine of negative b is equal to. I know what the sine of negative b is equal to. Those are the facts that I just proved. The cosine of the negative of some angle is just the same as the cosine of that angle. So I can replace cosine of negative b here with just cosine of b. And the sine of the negative of some angle is the negative of the sine of that angle. What I'm saying is I can replace the sine of negative b with the negative of the sine of b. And at this point, you could probably see the finish line. What I have written in blue is the exact same as what I have written in red. A positive times a negative is a negative. And if I add a positive number and a negative number, really all I'm doing is subtracting. What I have written in blue here is the sine of a times the cosine of b minus the cosine of a times the sine of b, which is exactly what I was hoping I could come up with, the angle subtraction formula for sine. And that same logic it'll turn out will work out for cosine. I can figure out the cosine of a minus b by considering the cosine of a plus negative b, because a plus negative b is the same as a minus b, but if I write it as a plus negative b, I can use my cosine angle addition formula. Playing the role of a in this formula is this a, playing the role of b in this formula is this negative b, so I copy what I see here except change all the b's to negative b's. And now, just like I did above, the cosine of negative b is the same as the cosine of b because cosine is an even function, and the sine of negative b is the negative of the sine of b because sine is an odd function. So what I get here is a negative term over here that I want to subtract. When you're subtracting a negative, you're really just adding. I got the sine of a times the sine of b as this second term, and what I ended up with is exactly the formula I was hoping I'd end up with, the cosine angle subtraction formula. What about tangent? Turns out the same thing's going to work, but if you're kind of clever and you could sort of follow the beats of these proofs, you might be like, wait, something's going to go wrong. I bet what you're going to do is you're going to say that the tangent of a minus b is the exact same as the tangent of a plus negative b, and you're going to write it this way so that you can use your tangent angle addition formula that you have up here. And in this formula, playing the role of the a is this a, and playing the role of b is this negative b. So I copy what I see here, again, changing the b's into negative b's. But then what do? You don't have any information written here about whether tangent is an even function or an odd function. However, because tangent is just sine over cosine, I don't need to start out with the knowledge of whether tangent is an even or odd function, because I can write the tangent of negative t as the sine of negative t divided by the cosine of negative t. And then since sine is an odd function, I can rewrite the top as the negative of the sine of t And since cosine is an even function, I can rewrite the bottom as the cosine of t. And what I now have written here is the negative of the tangent of t, because a negative divided by a positive is a negative number. So the tangent of negative t is equal to the negative of tangent of t. Because sine is an odd function and cosine is an even function, it turns out that tangent is an odd function. And with this knowledge, I can rewrite what I have here, changing the tangent of negative b up here in the numerator and the denominator into the negative of the tangent of b. So I got tangent of a plus the negative of the tangent of b. In other words, tangent of a minus the tangent of b. And down in the denominator, I got the tangent of a times the negative of the tangent of b. So this is a negative thing. I'm doing 1 minus that negative. When you're subtracting a negative, that's the same as adding. I got 1 plus the tangent of a times the tangent of b, which, sure enough, was exactly what I was hoping I'd come up with, the tangent angle subtraction formula. Kind of interesting, I think, how you can get the angle subtraction formulas almost immediately from the angle addition formulas, as long as you believe that the cosine and the sine are even and odd functions respectively.